So, Mr. Baldwin, we've got a really explosive subject today.
Absolutely. Love corny geology jokes.
Yeah, well.
I mean awesome geology jokes.
Yeah. Just like when the students say this class rocks versus it's rocky.
Perfect.
Yeah, right.
Oh my gosh, wonderful.
Okay, so we're going to cover one learning target today, and it is...
We're just going over types of volcanoes. So describe characteristics, different types of volcanoes. Okay, so for the first part, just some basic terminology. If you look at the volcano we have here, so this top part right here is the vent, and it's just the opening where the lava comes out. And then there's the volcanic pipe, which is basically just where it connects to the magma chamber.
So it's like the plumbing system of the volcano, right?
Mm-hmm.
Okay.
And then the crater is kind of near the vent, but it's this big bowl-shaped depression at the top. That's all the way, they call it the summit of the volcano. Okay? And then on the side, you'll notice we have kind of this like side volcano going on.
Okay.
And they call that a parasitic cone. So it's just a volcano that happens on the side, like a smaller volcano on the side.
Not all volcanoes have that, right?
Nope.
They're actually kind of rare, but sometimes there are parasitic cones. Okay.
Mm-hmm. And the last part, that's a fumarole. And basically, if this parasitic cone didn't have any magma in the pipe, and it was just emitting gas, then it would be a fumarole. Think like it's emitting fumes, so that's the fumarole part of it.
Okay, good. Some good terminology to start us off with. So I think the first we're going to talk about is going to be the shield volcano, which is absolutely the largest of the volcanoes. So we have lots of different volcanoes that are actually shield volcanoes. Probably the most common example given is the Big Island of Hawaii, which is a composite of several shield volcanoes. The neat thing about shield volcanoes is the ones that are forming islands have to start from the seafloor. So the majority of that structure is actually underwater.
So it's almost like the tip of the iceberg. It's like the tip of the volcano.
You're seeing just the tip top of it.
Oh my gosh.
So shield volcanoes are the biggest. They're also a shield shape, so they're very low slope. They're very broad and domed.
So you can see in the picture here, it's really low sloped. It'd be a nice easy walk to go up to the top, right?
It would be.
Yeah.
It would be. And the reason that they're low slopes like that is because they have typically very high temperature, very low silica, basaltic lava flows. And because they are high temperature, low silica, very low amounts of dissolved gases, those lavas can flow for a long distance.
Okay.
And so they just spread out over a long distance, giving it its characteristic flat slope, shield kind of structure.
So these wouldn't have big eruptions. They would just be kind of quietly oozing out.
Quietly oozing out, or actually some really beautiful lava fountains, very picturesque, where you can almost walk up to them and watch those beautiful eruptions, or you can get pretty close to some of those lava flows on Hawaii and still kind of walk away from them. But they can still be fairly destructive.
Okay.
Right? So we find these associated with hotspots, and sometimes we find them associated with divergent plate boundaries. For example, Iceland is a huge shield volcano that's over a hotter area of that mid-Atlantic ridge.
Okay.
So some other examples, Galapagos Islands and Easter Island.
Yeah. Cool. So the second one, we're taking a bit of, we're shrinking it a little bit. It's a lot smaller. So we're doing composite or stratovolcanoes. And these are like our picturesque volcanoes. Like they look like volcanoes. So they've got these really steep summits, but then the flanks, like the sides, are kind of tapered off a little bit.
Yeah.
And you can see that beautiful, we said this was Mount Fuji?
That's Mount Fuji. Yeah.
Mount Fuji. So it's got this really steep summit here, and then it's kind of gradual off onto the side.
Right.
And then this one, you told me the names of these.
Those are probably Itza and Popo, and those are volcanoes that are close to Mexico City.
Okay. And again, they just look like volcanoes. This is classic what it looks like in like third grade class, what you would build out of it. They've got more andesitic lavas, so they're kind of intermediate, right in the middle of mafic and felsic, and they'd be a lot more explosive. Okay, and the reason they call them composite or strato is because they come in layers. So when they have these big eruptions, the lava would flow down the sides, and then all the ash and the pyroclastic material would kind of settle down on top of it. So you'd have like this layered effect of each eruption.
Okay, and the composite cones are typical in a convergent plate boundary, right? So all around the ring of fire. In other words, the majority of the volcanoes, which are all around that ring of fire, are going to be composite cones. It's really interesting to think about why they have those explosive eruptions. And in part, that's due to the fact that the sediment that gets dragged down in a convergent plate boundary is really wet sediment. So you're adding a lot of water to that magma initially, and it's got all those volatiles there, and that's what's causing the explosive nature. So it's actually forcing it out under high pressure and shattering the lava that's there, and that's what forms the ash.
Okay, so it's because of water they become more explosive.
Yeah, and it's the water that comes from the sediment on the ocean floor that gets dragged down in the convergent plate boundary.
Okay.
Yeah.
Cool. Last type?
Last type?
We've got the cinder cone. These are like the little baby volcanoes.
Yeah.
Okay, smallest of them all, about less than 1,000 feet tall. Amazingly steep, 30 to 40 degrees.
Yeah.
And you guys can see, here's a picture. This one you told me was Sunset Crater.
in Arizona.
We've got Paracutin in Mexico.
Yep.
And then Wizard Island, which is actually in the middle of a crater that's filled with water. So they're usually those parasitic cones that we saw. So they're associated with other volcanoes.
Yep.
And they're really explosive, but like small explosive. So we see a lot of pyroclastics, a lot of material thrown up into the air. Scoria, which is a type of mafic rock. And then cinders that we have coming out of it.
Yeah, good. All right, so we've got those different types of volcanoes, and I think you got a quiz on these, so go ahead and jump on your class webpage and take your quiz, and we'll see you in class.
See you guys tomorrow.
Bye.